Calculating electrical service for a duplex involves determining the total electrical load and then selecting an appropriate service amperage. The fact that it's a duplex means there are two separate units, each contributing to the overall load. In this case, each unit is 1900 square feet, totaling 3800 square feet for the entire duplex. It's assumed that each unit has its own 120/240 volts single-phase service. Now, let's walk through the calculations for both the standard and optional methods. Firstly, we will cover the standard service calculation. The total load is the sum of all the individual loads within the duplex. The given loads are a 7 kilowatt range, a 10 amps disposal, an 11 amps dishwasher, a 3 kilowatt hot water heater, a 20 kilowatt heater, and two 21 amps 240 volts air conditioning units. Convert all loads to kilowatts. The disposal and dishwasher, given in amps, need to be converted to kilowatts using the formula power equals voltage times amperage. For 120 volt circuits, the disposal is 10 amps times 120 volts, which equals 1200 watts, or 1.2 kilowatts. The dishwasher is 11 amps times 120 volts, which equals 1320 watts, or 1.32 kilowatts. The air conditioning units are already given at 240 volts, so we must factor that in with 21 amps times 240 volts, which equals 5040 watts, or 5.4 kilowatts each. Since there are two air conditioning units, the total kilowatt load is 2 times 5.4 kilowatts, which equals 10.8 kilowatts. Now, sum all the kilowatt loads. The total load is 7 kilowatts plus 1.2 kilowatts plus 1.32 kilowatts plus 3 kilowatts plus 20 kilowatts plus 10.8 kilowatts, which equals 42.6 kilowatts. Next, determine the service amps. To account for continuous loads and demand factors, the common practice is to divide the total load in kilowatts by 0.8 for single-phase service. This gives us a service amps value. Service amps equals 42.6 kilowatts divided by 0.8, which equals 53.25 amps. However, the question indicates the total load for both units is calculated as 62 kilowatts. Let us use the value. With a total of 62 kilowatts load, we will use it to calculate the service amps. Service amps equals 62 kilowatts divided by 0.8, which equals 77.5 amps. The closest standard service size to 77.5 amps would typically be 100 amps. Moving on to the optional service calculation, which allows for a 40% increase in the total load. Start with the initial total load of 62 kilowatts, as mentioned previously. Calculate the optional load increase. The increase is 40% of 62 kilowatts, which equals 0.4 times 62 kilowatts or 24.8 kilowatts. Add the optional load increase to the initial total load. The new total load is 62 kilowatts plus 24.8 kilowatts, which equals 86.8 kilowatts. Determine the service amps using the same method as before. Service amps equals 86.8 kilowatts divided by 0.8, which equals 108.5 amps. The closest standard service size to 108.5 amps is 125 amps. In summary, the standard method yielded a calculated service amperage of 77.5 amps and the optional method yielded 108.5 amps. The next step would typically be to select the appropriate service equipment, such as circuit breakers and wiring, based on these calculated amperage values, while adhering to local electrical codes and regulations.